I want to talk to you about AI, in particular about human-centered AI, and how that is transforming businesses and has the potential to transform every business. 3 years ago, we all got together. Back then, it was open world, and this is the next time that the Oracle community has gone together is today. I launched Vian, my company, at that event 3 years ago. And at the time, I made some observations about the state of AI, what was happening with AI in the enterprise. And in preparation for today, I was reflecting on that presentation. I had 3 observations that I made at the time. The first one was that there were some incredibly impressive advances in AI, but also that there was a lot of hype. At the time, there were different examples of the kinds of achievements that had been made. I also observed that AI continues to have some very serious limitations, and also that the talent, the investments around AI are very asymmetric. But that with the right approach, AI has the potential to really transform businesses. And as I was reflecting on my talk today, I realized that basically these 3 points are still exactly the same. They are still valid. Still impressive achievements. Last week, we heard news of an AI system using reinforcement learning and something called tensor folding to invent a matrix multiplication algorithm on its own, which is more efficient than the most efficient known matrix multiplication algorithm. This is quite incredible. Protein folding, the image generation stuff, and so on. So really impressive achievement, but also the hype still continues the same way as it was 3 years ago. A little bit disappointingly, the limitations of AI, what manifests as bias, ethics, lack of transparency, lack of explainability, these are still unaddressed. There is a lot more awareness of these, a lot more work on addressing these, but by and large, these problems still remain. They manifest in the form of stories of bias, stories of mistakes happening. Of course, catastrophic things like accidents in self-driving systems and so on. And also, the skills gap in AI is as severe today as it was back then. And at the same time, the cost performance of AI has become quite visible, quite apparent. The large language models now cost millions of dollars to train. More and more specialized hardware is being built to run AI workloads. And the cost as well as the execution performance of AI continues to be a major issue. So all of those issues are still there. And so I think when we think about how enterprises should get around these problems and to unleash the transformative potential of AI, it really comes down to understanding these kinds of limitations. And last week I spoke to John Etchemendy, Professor Etchemendy. He is the head of Stanford's Human-Centered AI Institute. And we discussed the state of AI and that I was going to do this speech, and he gave me this quote to use today. There has never been a more urgent need for a human-centered approach to AI. Advances have opened new frontiers and enabled great applications, but a lot more needs to be done to make AI trustworthy, unbiased, cost-effective, and high-performing, and more widely available. This ability to deliver trustworthy, reliable AI, human-centered AI, is at the heart of our mission to bring AI to enterprises. And that's what I want to talk to you about today. So that's what we do, human-centered AI. And in particular, we believe that in order for AI to be useful, to be relevant to enterprises, it needs to have these three characteristics. It has to be in the service of business outcomes, obviously. It has to be responsible, trustworthy, and sustainable. And it has to be optimized for cost and performance. Even I serve on the board of BMW. Even massive companies find it difficult to deal with the cost and performance of AI. And when CEOs ask me, what is the main advice that you have, Vishal, for using AI? And I always tell them the same thing. First, find the right applications that empower your people, that put people in the center. If you heard Larry's keynote earlier, he talked about patients being at the center of this new healthcare system, the vision that he has. So human-centered applications have to be at the center of what we do. And from a technology point of view, the trustworthiness that comes in the form of a bracket around the AI systems to monitor the systems, to make sure that the systems work reliably, a platform for enabling a continuous monitoring of these systems to make sure that they continue to do the right thing, and technologies to optimize the cost and performance of AI systems. So these are the three things that we do: applications and two particular types of technology. So let's talk about the first of these applications. When we were thinking about how do we bring trustworthy human-centered AI in applications, we realized that one of the things that is missing in AI is the ability to understand cause and effect, causal intelligence. It is a relatively recent field of study. I mean, the causality in statistics has been studied for a long time, but bringing it into AI is something that has happened relatively recently. In fact, the 3 Nobel Prize winners in economics last year were all awarded that prize because of their pioneering work in causality. And so we were thinking about various domains where this could be applied. And we decided to apply this to digital customer engagement. With COVID, the world became digital in a much more accelerated way than what was happening. There was already a transformation happening towards digital engagements and digital everything, remote everything. COVID accelerated that by several years. And when you think about digital customer engagements, over the last 10 years, customers have built CDPs like Oracle's Unity. And then you predict what customers' behavior will likely be. But as we were thinking about this application, we realized that we need to go beyond predicting. A lot of times, for example, in telco, customer churn, you can predict which customer is likely to leave. And even if you are correct, it turns out that a very mysterious and interesting behavior happens. A lot of customers, the lingo for this is sleeping dogs, are not aware that they are paying for a subscription. And when you reach out to them with an offer, they actually end up leaving because they all of a sudden become aware that they had a subscription. What you instead want to do is to be prescriptive about what you're trying to do, the outcome that you're trying to achieve, which is that which are the customers that if they were made an offer are likely to respond to that offer. That is an entirely different question, and that requires understanding the cause and effect relationship. And so we call this revenue science. We built the application together with Dealtail. So you can go to dealtail.com and check this out for yourself. It involves taking all the customer engagement data, applying causality to that to understand really where the causal relationships are between offers and the outcomes, or offers and the actions that the customers take. So the way it works is we take all of the customer engagement data out of a whole bunch of systems. Combine that using a no-code platform. So marketing analysts, marketing technology people can combine this into a single view, large view of all the customer engagements. And then we can build customer journeys out of that. That how were the interactions materialized over time, what offers were made to customers, how did they react to them. And on top of this, we do the causal analysis to realize what are the real causal relationships that affect the outcomes. And those are then used to come up with new offers, new products, things like that. And the end result of this is that customers see a dramatic improvement in the effectiveness of their customer engagements. So NetApp is one of our customers. They saw a tremendous improvement in conversions and in ROI for the digital engagement strategies. And similarly, Worthy is a consumer marketplace for jewelry. Amir is the CTO and co-founder of Worthy. They saw such an amazing result, the improvement of conversions by 15% because of this understanding of causal relationships, that our team and Worthy's team wrote a paper jointly about this work. And this system is at dealtail.com. It is being used by close to 50 companies. All of these are digital-first, tech-first companies. A large majority of these are unicorns, not because of their valuation by some venture firms, but because they are innovating in their industries, and they are incredibly successful companies, and to keep up with their high growth and the effectiveness of the sales engagement, they work with us. So this is our first of our applications. You can check it out. It is ready for use today. Going beyond this on the applications, we are thinking about bringing human-centered AI applications. We are working on next generation human-centered AI applications with a large variety of companies. We have been working with some of the largest banks, insurance companies, manufacturers in the world in creating human-centered AI applications. And you see a few examples here. For some of their most critical business areas, strategic business areas, where AI can have a transformative effect, whether it is in supply chain or analyzing massive amounts of information, including unstructured information, now that it is possible to do that with language models and so on. We will be launching more and more of these, and we would love to work with those of you who are interested in bringing AI to some of the strategic business areas. So this is applications. Alan Kay once said that the people who are really serious about applications build their own technology. And all of our applications use our own technology. But I believe that the two areas that I told you about earlier have their own relevance, have their own use in the enterprise. And I want to talk to you about those. The first one is around getting a handle on the AI landscape today, in particular on monitoring. So monitoring, smart monitoring and continuous operations of AI is an incredibly important capability that is needed more and more by enterprises today. If you have models that you have deployed for critical business areas, you need this. Why do we need monitoring of models any more than monitoring of regular software? Well, a model by its nature is a kind of a reflection of some process in reality, whether it is fraud or predicting whether a machine is going to fail or whether there is money laundering happening in this particular transaction, or if you want to approve this or reject this transaction. Any of these kinds of models that capture these phenomena, by their nature, over time they drift. The reality that they see in the course of their deployment may not be the way the reality was when these models were trained, or the data sets that the data scientists were given to build these models may have changed, and all of these kinds of things. And the nature of fraud itself changes, the nature of spam changes every day, and so on. So it becomes very important to understand whether the model that I have in deployment is still doing a good job, what it means for a model to do a good job, what it means for it to drift, what are the acceptable boundaries, all of these kinds of things, and to be able to do that in real time. There are additional aspects of that dealing with things like uncertainty. So it could be that when you trained the model, the way you looked at the world was not exactly the same as the way the world is now, or the kinds of data that you see now are of a different nature. And so the model that you have built is not particularly confident about achieving results in those areas. Bias, fairness are all manifestations of this ability, and that applies not just to the model but also to the data itself. So the ability to do this, to make it actionable, to deal with this kind of a dynamic world, is incredibly important. And that is our platform that sits underneath our applications, enables us to do that. Here is what it looks like. And we have designed this for massive scale. A lot of enterprises are, here is a quote from one of our largest customers. This is one of the world's largest payments processing company. They do in the neighborhood of 1 billion transactional approvals or rejections every day, 1.1 billion. So as you can see in the quote here, it's several 100,000 events per second. So this is a payment processor that is processing about 15,000 transactions per second, up to a peak of 80,000 transactions per second, which then explode out into hundreds of thousands of events per second. And these need to be monitored, that Bob swiped a credit card at a Starbucks in the Venetian. Does this need to be approved or not? And that model that determines whether to approve or reject these transactions, that model needs to be monitored continuously across these billions of transactions. And so the breakthrough for us is the sheer scale at which we can now monitor our models with customized monitoring across the large number of features. Some of these features might be short-lived, some might be long-lived, and so on. So to be able to do this over millions of transactions per day, we tested this on more than 95 million transactions in a quarter, and we have the ability to do drift detection of every single transaction, and comparing that against the last 95 billion transactions that were done in the trailing 90-day period. So this is an incredibly powerful ability. So if you have models that your business relies on, and certain part of the business relies on, that need to be monitored, this is an incredibly important capability for it. You can go to our booth and take a look at it, get a demo of this, and sign up to be a Charter customer for this. And the third part of my talk is around performance of AI. As the models have become larger over the years, they are astonishingly larger now. GPT-3, I think, had 175 billion parameters on it. Google recently released, back in June of this year, a language model called PaLM that has more than 500 billion parameters. Back when I was a student, we used to build neural networks that had 10 parameters in them. And you could observe what every one of those was doing and all that. 540 billion parameters. And it takes tens of millions of dollars to train these. If you are deploying one of these models in a car to do obstacle detection and things like this, it is extremely important that you are able to do these things in real time with low power consumption and so on. So this is an incredibly important dimension of AI. And we have been working very hard on this particular problem, and I'm really excited to announce this particular thing today. We have been working on two aspects of this. We haven't touched the language models yet, but we have been working with widely used computer vision models, and obviously models were built on tabular data. So these two categories of models, we have been working on accelerating and on shrinking the footprint of these. So one of the most iconic car companies in the world has been working with us on accelerating their vision models. That it's an incredibly complex model that takes a 1024 by 512 picture and processes that. And we are able to accelerate the inference on that by 4 times. And we shrunk down that model to 5 times, one-fifth the size of that model. Now you have to understand that this is a model that is continuously running, detecting whether you are in the lane or not, if there is an obstacle in front of you or not, and all of these things. And it is consuming the same battery that the car itself is moving on. So the more that you can save on the battery, the faster that you can do this processing, the better everybody is. You save more battery for the driving itself. The system, in fact, becomes safer because with a 4x acceleration, you can improve the frame rate by that much. So we are really excited about this. 4x acceleration in inference on vision model for autonomous driving, and 5x shrinking of this model. Same in the case of one of the largest consumer internet companies with a massive audience worldwide, one of the biggest consumer internet firms. They obviously have an even more complex stack and even more complex data set that they run on. We were able to get close to 3x inference acceleration on that, but a 27 times shrinking of the model. And the result of that is much lower costs of running the AI and machine learning inference in the data center. So earlier today, Jensen was on stage with Safra talking about NVIDIA's partnership with Oracle. All of this is in this direction of improving the performance. We obviously do it in software. Our acceleration work is in software, regardless, independent of the hardware that runs on it. So all of these numbers are on the same hardware that these models were running on before. And another vision case was for a large semiconductor company where we were able to achieve a 10x acceleration of inference. So this model is a little simpler than the model. Still a very complex. It is based on OGG, which is one of the big vision models, but it is simpler than the one for the consumer internet giant that I mentioned earlier. But we were able to accelerate that by 10 times and shrink this model down by 27 times. And that leads to a dramatic set of business benefits as well. Improved defect detection in the wafers, because you have these vision models detecting if the wafers that are falling off the assembly line are still okay or not, and that kind of thing, and improving the yield of that wafer manufacturing process. So that's for vision. Tabular data is, it turns out that in enterprises, a vast majority of models are in fact built on tabular data. And when I was thinking about when the pandemic started, we started working on this particular problem. We started with tabular data. And I worked on this myself as well. The very first data set we worked on was diabetes. My mom had diabetes. That was the primary reason that she died relatively young. And we worked on accelerating the diabetes model as our little guinea pig. And I'm very happy to report today that we can dramatically accelerate tabular models. In this particular case, network firewall security, we were able to achieve more than 100 times acceleration of models runtime, inference time, and shrunk the footprint of that model by more than 300 times. And what that means is within the network, you can now run state-of-the-art AI models without taxing the firewalls or the routers, which have limited compute capacity. And I'll share one other example with you that is in the area of predictive maintenance in edge equipment. A lot of manufacturing companies have equipment sitting on the edge, whether it is industrial controllers or computers sitting on oil rigs. A car, in a way, the computing in a car is an example of an edge machine. A lot of times, these edge machines they live for decades. It is not possible to upgrade the hardware in these edge machines. So you need to be able to run state-of-the-art, high-quality AI models on these. But usually these models are too big to run on edge devices. And often you don't have the ability to run the AI models on the cloud and have them talk to the edge device. So to be able to shrink down AI models and to be able to run them on the existing hardware in the edge device is something that is extremely important to companies that, so this was a predictive maintenance model running on Intel Atom processors running on an edge computing device. And we were able to accelerate these depending on which framework the model ran on the same edge hardware by between 100 times to 1,000 times. That's not percentages, that is a times, 1,000 times. And the compute footprint reduction is generally 3x that. So in the 100x case, it was around 300 times shrinking. And in the 1000x case, it was 2,500. And Schneider Electric, by the way, the flowers are beautiful. Schneider Electric is one of the great electric companies in the world, also a huge Oracle customer. Peter is the chief data officer there, a member of the executive board. We worked with his team. AI plays a huge role for them. The electrical equipment that sits on edges, like in this case, the oil pumps, but in all kinds of machines that Schneider has. And we were able to, as he writes here, demonstrate well above 100x improvement in AI model execution speed on the same hardware. So I'm really excited to launch today here at Cloud World the Performance Acceleration Technology Preview. You can see this for yourself and try this out. It's limited. We are limiting it for now to binary classification models on tabular data only. It looks like this. You upload a model with some training data, and you get back a reduced model that runs faster. And one interesting aspect of this is it only runs on the Oracle Cloud. So check it out. Here is a QR code for it, or you can go to bit.ly/YNI and take a look at that. So those are the three things: transformative business applications that use human-centered AI to deliver rapid value, and Dealtail being the first example of it. Monitoring, dynamic, smart monitoring of model behavior and performance designed for a dynamic world. And rapid acceleration and shrinking of the most widely used vision and tabular models. Man, this is such a beautiful picture. That's a hummingbird. A few years ago, I read a wonderful paper which said that hummingbirds can see colors that humans cannot even imagine. I mean, we like to think we have pretty rich eyes, a very rich retina. But it turns out that hummingbirds can see things including in the ultraviolet range and also in the infrared range. Birds, we have a pejorative term, bird brain, but it turns out that birds have pretty sophisticated brains. They understand causal relationships. They can understand hidden causal agents where there is a phenomenon that they observe where the cause of that phenomenon may not be visible to them, but they can figure out that, oh, there is something that is causing these things. quite fascinating. Their cognitive ability is quite strong. And when the pandemic happened, there was a very interesting behavior. The birds that migrate around the Golden Gate Bridge, some of the scientists studied this. The nature of the bird song, the song that they have to communicate with other birds, the nature of that song changed because when the lockdowns happened in the pandemic, the noise levels went significantly down. And so the birds very quickly realized that they didn't have to sing quite as loudly or in quite as shrill, lower frequency a manner as they did before. And so the bird song actually became much softer and much more beautiful. It's a great example of monitoring for drift in birds. And all of this happens in a hummingbird consumes about 7 calories in a day. 7 calories. That is, we generally consume about 2,000 calories, which is about a 100-watt light bulb. So that means that 200 hummingbirds together is like one of these 100-watt light bulbs. It's quite astonishing. We still have a long way to go in AI. And we are taking with all 3 of those things, causality, monitoring, and performance acceleration, we are taking steps to advance this state of the art. But a lot of people ask me, about full autonomy and all of these kinds of things. We are nowhere close to having an AI system that could replace our judgment, our wisdom. The best we can do right now with AI is to augment our abilities, augment our perception, amplify our ability by using these powerful technologies, not so that the system can replace our ability to decide or our ability to act, but that it can enhance that. So for the next many decades, rest of our lives, of all the audience here, the important thing to remember about AI is what Alan Kay said, that the music is not in the piano. The music happens because you play the piano and the human and the piano come together. So that's what we are working on, AI applications and technology on Oracle Cloud Infrastructure, and we would love to work with you. Thank you so much.